Let's look at the future capabilities of FutureGrid as it moves forward. This comes from the overview, some of the lessons learned from FutureGrid. An important lesson was that computer science and middleware was a large use. Another lesson was that education and training was a large use. Those were not expected to the extent that we saw them. They were included in our proposal, but not expected to be so important. Another issue that we probably expected but didn't know the implications of was the rapid change of technology. We started with eucalyptus, then we added a lot of energy into Nimbus because eucalyptus did not run quite as well when it was commercialized, and the open source version languished a little. It's now got much better, but for a while it was did not meet the capabilities needed by FutureGrid. And now, of course, Nimbus is probably less popular than OpenStack, which is the technology most used by current projects. This evolution and maturing of infrastructure as a service software was seen in this news headline that PayPal drops VMware from 80,000 servers and is replacing it with OpenStack. There was a Forbes headline. And then there was another headline saying that VMware loses $2 billion in market cap. Due to this, it's expected that eBay will actually, or at least switch from VMware to OpenStack more broadly, because PayPal is owned by eBay. Now, that doesn't mean that everybody will do that, because eBay is an example of a company with major internal technology expertise. Most users of virtual machines do not have that expertise. So this does not mean that commercial virtual machine managers are no longer interesting. It just means that companies which have lots of internal expertise, or organizations, can expect to use open source software effectively. Another important set of lessons from FutureGrid is the usage mode, namely it's interactive, not batch, and that all the jobs are short. When we started, we didn't really know what we were doing and what was needed, and we found the testbed as a service technology we've discussed already, and we'll discuss a little more later on, that was needed, and we developed RAIN, Cloud Mesh, and we actually just developed the operational model for running the cloud testbed, which was not known to us. I would say if you look at the well-known DOE cloud experiment with Magellan and FutureGrid is somewhat more positive on the value of clouds than Magellan, but that just reflects largely our usage goal. We were aimed at experimentation and research, especially in computer science and in education and training. Magellan was aimed at science clouds, where the current limitation of clouds and performance, and when they were running software functionality, were relatively serious. There are still performance problems in clouds, especially when you have devices such as InfiniBand network devices, or GPUs, and linking those into virtual machines. But those performance problems are expected to get much better, and they should, in some sense, go away, because people can learn how to build the software to realize the native hardware performance there. And in fact, one can, in some experiments, actually get decent performance. So there's a particular Linux OS and a particular Mellanox driver gives you good performance on InfiniBand on clouds, but that's not a universal characteristic. We would claim to have specified the type of hardware you need. I mentioned some of the mistakes we made, not enough disk, and how we needed multiple networks to support the different networking models of different clouds. So when we build FutureGrid again, we will know how to do it in a better fashion. An important characteristic I mentioned already under the hardware section, that the system needs to be integrated in terms of the users, the software team, and the systems team, because this technology, such as Nimbus or Eucalyptus or OpenStack or Hadoop, is rapidly evolving, and you're not going to get a good experience unless you link all the different components, from the raw support to the people tweaking the software to the people using the software. They need to be a team. And the last comment here is, when we started, the concept of a computer test bed as a service didn't really exist. Now we're trying to develop that community. As we look to the future for FutureGrid, we're poised to support more users because technology like OpenStack is maturing. And we welcome new users and new challenges. We expect there to be more interest in platform as a service, and higher level middleware such as Hadoop, HBase, MongoDB, and as most of our effort now is spent at the infrastructure level, because that's just so hard that we don't have any cycles left to do much at the platform level. But we expect as OpenStack and possibly other systems mature, one can spend more of one's effort at the platform level. We also see important new big data challenges. This particular MOOC suggests our interest in improving education and training by making FutureGrid a lab for MOOCs, so that you can have your massive online course and have people do their parallel computing or cloud laboratories on FutureGrid. We've discussed Cloud Mesh, which is basically an environment to support cloud bursting and between different cloud environments, so you can develop your system on FutureGrid, run it on Amazon, or run it on a different science cloud, and that we see as an important capability. I've already mentioned that when we started, the interface to the infrastructure as a service was relatively primitive and difficult for some people. Now we're getting quite nice user interfaces such as Nimbus Phantom and OpenStack Horizon, which will be important foci of future support. I've already discussed that we need to work with Genie, and we need to get high-performance virtualized devices for the mic and the GPU systems, and we're going to get this software-defined system model. I doubt if you can ever have too much monitoring in a system like FutureGrid, because the people using FutureGrid will want to measure what they do, so they need to have good monitors which tell you what the system is doing. An area where I think still a lot of work is needed is what it means to do reproducible experiments, and what a reproducible experiment management system really needs to have in it. And finally, our hardware is now over 3 years old, and it has still more life in it, but it's going to need to be expanded and renewed if we're to continue to serve users. One area I think of as expanding is current users who want to do large-scale experiments, say test Hadoop on 1,000 nodes. They cannot do that on FutureGrid. So we need to have the ability to do that. I doubt if we'll get a 1,000-node cluster just for FutureGrid. So that means we're going to have a collaboration and a partnership with people who can supply that capability on demand.